The derivative of arctan of the square root of x minus 1 requires the chain rule. So what is the chain rule? The chain rule is differentiating a composite function, so a function within a function. So for example, f of g of x. So when we differentiate this composite function, what we do is we first differentiate the outermost function, or the f function, and we keep the inner function as the placeholder variable. And then we multiply this derivative by the derivative of the inner function, or g of x. So as you can see, symbolically and mathematically, that's how it's written, what I've just explained. So to do this derivative here, the arctan of the square root of x minus 1, we first must differentiate the outermost function, which is arctan. So that is 1 over 1 plus, and now keeping our inner function as our placeholder variable, x minus 1, and that's squared. Okay, now we have to differentiate this inner function, which is the function that's the next furthest out after our arctan. So that's the square root of x minus 1. So the derivative of the square root of x minus 1 is the same as the derivative of x minus 1 to the power of 1 over 2. So what I've said is x minus 1 square rooted is equal to x minus 1 to the power of 1 over 2. Okay, so now using the power rule, we multiply x minus 1 by 1 over 2, and we decrease its exponent by 1. So 1 over 2 minus 1 gives us negative 1 over 2. All right, now simplifying the right-hand side, when we're squaring a square root, they both fall away, and we get, in the denominator, we get 1 plus x minus 1, so then the 1's fall away, and we're left with 1 over x, and that's times by 1 over 2, and that's times by 1 over x minus 1, and then the square root of that. And I brought this x minus 1 into the denominator because its exponent was negative. So our final answer is 1 over 2x into the square root of x minus 1. I hope this video helped clarify the chain rule for you. If you enjoyed it, please don't forget to leave this video a like, or if you learned something too. And please could you subscribe to my channel? It really does help me out. Thank you.